We are out here in beautiful Bruneau Sand Dune State Park, just outside of Boise, to think about how we can connect up these sand dunes and the kind of physical processes happening here on the Earth to the same kind of physical processes happening on other worlds like Mars, Saturn's moon Titan. We see dunes all throughout the solar system, and the processes that govern dune formation and evolution here on the Earth translate, we think, to those other worlds. And so by studying planetary analog sites like this one, we could better understand the processes that shape the surfaces of distant worlds. And we're here at Bruneau with a huge team of planetary scientists and engineers who are all interested in addressing these kinds of questions. How and when does sand move on the surface of a planet? And so we've got a big setup of different kinds of instruments to measure the winds, to measure sand motion, to try to address those kinds of questions, potentially with new and ongoing NASA missions. The instrument setup that we have here is stationary. So a lot of folks are familiar with rovers rolling around on the surface of Mars, and that's really an effective way to explore the surface, but it's also a very expensive and complicated way. And so we're here exploring a landing concept that would be stationary. It would land at one point on Mars and then try to understand the processes going on at that site. And so that has some advantages in terms of cost and engineering, but of course it means that we're not mobile. And so we have to select our landing site very carefully. We have to do the engineering and science development very carefully to deal with the fact that once we're at that place and in that spot, we're not going anywhere. So we have to think through those kinds of questions very carefully here. And that's what the point of this demonstration is today.
So I'm a scientist that studies active present-day processes on other planetary bodies, especially those involving kind of the atmosphere and surface interactions. So things like how the wind blows the sand around. Like the dunes on Earth, the same as dunes on Mars, they're forming through the same process, but you have a different atmosphere, you have a different gravity, you have different grains. So factoring those in gives us a better understanding of the physics. So we're all here talking about, okay, how do we collect those measurements that are needed to really advance the science? We've got missions currently that are on Mars. We have missions planned to go to Titan and Venus. These are under development and have launch dates with NASA. And as we send those spacecraft, understanding the processes is going to just enable us to better interpret the results and really expand how much knowledge we can be getting out of that, of understanding what's happening in our solar system and maybe even what's happening in other solar systems.
Boise State got involved in this partnership with NASA and the Jet Propulsion Labs because my research group does a variety of field experimentation related to the motion of sand and dust on the surface of the Earth, trying to understand how those motions can translate to Mars and other worlds. And so this partnership is meant to develop this important mission concept, but also to develop opportunities for Boise State and Boise State students. This kind of thing is just really unprecedented for Boise State, being involved at this level with a NASA mission. So we're really excited to be able to be out here today with all these partners and think through all these science and engineering concepts.